Hello, IB. 22H.1 is sets and Venn diagrams. So you guys have been using different notation for finding the probability using tree diagrams and Venn diagrams. So now what's the proper notation that we want you to use and to recognize in IB questions? So a universal set is just the collection of whatever the things are we're talking about in the question, because a set is just a collection of various things. So obviously here we're going to be talking about numbers. The universal set is denoted with the letter U, and we're going to talk about integers between 0 and 10. So the word between means not including 0 and 10. So when we use a subset, A is going to be just the even integers. We'll include 2, 4, 6, and 8. And then when we talk about the number of elements in a set, we use this little n of set A. So this little n of set A means the number of elements in set A, which we have 4. 1, 2, 3, 4 elements in set A. The complement is, so when we're talking about probability, you see the same notation that you would for derivative. But remember, with probability, this means complement and not derivative. There's nothing to take the derivative of. So similar notation, but in different context. Complement of A is A with the apostrophe, just meaning everything that's in our universal set, but not in our set A. So we're still talking about numbers between 0 and 10, but we're not including 2, 4, 6, 8. So we will include 1, 3, 5, and 7. X is an element of the set A, so we say X is, and then we have this E, it looks like an E, to say that it's an element of set A, or X is not an element of set A. So if X is an element of set A, it would be an even integer. If X is not an element of set A, then it would be one of our odd integers. And I'm going to include, forgot to add 9 in here. All right, so including 9 as well. So when we take this information and make our Venn diagram, this entire rectangle is our universal set. So the universal set includes all integers between 0 and 10. Then we have a set of A that we include our 2, our 4, our 6, and our 8. Anything that's not in A would go outside the circle, so the 1, the 3, the 5, 7, and the 9. So if we say the probability of being in set A, we're looking at what is in set A. We have 4 elements in set A. We have 7 elements, let's see, 9 elements, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements total, right, between 0 and 10, absolutely. So 4 out of 9 is our probability of being in set A. When we discuss 2 separate sets that are in our universal set, so we have, here's our universe, and we have now 2 separate sets, A and B. When we talk about the intersection, we're talking about the overlap. So think about a car intersection. It's where your cars could possibly overlap, hopefully not. If we discuss this, a good example might be if we say that set A is maybe our SL course content, set B is maybe our HL course content for IB. There's a little bit of overlap, and then there's some things that are just in the classes individually, and then there's some topics that might not be in the courses as well. But when we talk about the intersection, we're talking about X being an element of A and also X being an element of B. If we're looking at the union, we're not only talking about the intersection in the middle, but we're including everything that's also just in set A and everything that's also just in set B. So for this one, we might be saying we have either information that's in SL or in HL or possibly in both. So when we use that word or, we're saying that X is an element of A or X is an element of set B. But when we say or, it means you can also possibly be in both. So that is our union. You can also think of union like a marriage, right? It's the 2 people in the middle, and then you have the 2 families as well. So it's not just the overlap of the 2 people. Whereas an intersection would just be those 2 people. All right, a disjoint set or mutually exclusive would mean there's no intersection whatsoever. So if you were thinking about what the intersection would be represented as, it would be the empty set, also the null set. All right, so there's absolutely no overlap whatsoever. The 2 sets would be completely mutually exclusive. So that would be as if our SL and our HL course had no content that overlapped, whereas we know that's not true. All right, so for our SL and HL courses, there is a little bit of overlap. Our SL Science maybe and SL English, maybe those are two courses that completely do not overlap. So that we could say they're mutually exclusive courses. All right, so another important feature is not just applying it to a situation, but also knowing what you're actually looking for in the Venn diagram so you can apply it to various situations. So for this question, it says on separate Venn diagrams, which we have here, you have two events, A and B, that intersect, shade the region that represents A, but not in B. So here we're talking about our element X, such that X is an element of A, but not in B. So we can say intersect with the complement of B. So what we're looking for here is we want to be in this set A. So here's A. We want to be here, but we do not want to include B because it says and the complement of B. So we don't want to include this little bit that overlaps with B. So what we're actually looking for is just this piece, not including that overlap bit. So just this part here, that's only in A, but doesn't include the bit that's in B. Similarly, neither in A nor B would mean not in A and not in B, or if we're not in A and we're not in B, we're going to be out here somewhere. So if this is where we're talking about, really that's the complement of the union because we're not including either A or B. So you could also say if you had the union of A and B, you could take the complement, and therefore we could say we want the set of all values X such that X is an element of the complement of the union. All right, so just think about what you're actually describing. What part of the Venn diagram do you actually want to be talking about? And then we'll have to set up using our notation correctly. Go ahead and pause the video here and try this example from 22H.1. So let A be the set of all factors of 6. B is going to be the set of all positive, even integers that are less than 11. So your union is going to be the elements of X such that X is between 1 and 10, including 1 and including 10. And X is going to be an integer. So remember this Z with the double line is the set of integers. All right, so that's our universal set. Describe A and B using our notation. Show them in a Venn diagram what values you actually have. And then let's go ahead and find the number of elements in A union B, and A intersect B. When you're ready, go ahead and check that you agree with our answers to A and B. And then part C. Number 11 uses a Venn diagram with 3 different sets in it, and we have 40 people total who have watched different types of television. M represents movies, S represents sports, and D represents drama. If you're given that 10 people have watched a movie last night, calculate the values of A and B. So they've left 2 values that are unknown. Enough information is given, though, that you can figure out what A and B actually are. So given that 10 people have watched a movie last night, if we look in this movie set, we have 4, 5, 6, 7 people already allocated. So we have 3 people left over to just have watched a movie and drama, not including sport. Then for B, since I know the total number of people needs to be 40, if I add up all my values and I include the 9 who didn't watch anything last night, I should be able to figure out what B is. So B actually also winds up being 3. All right, find the probability that one of these individuals selected at random watched sport. Okay, so if you randomly select one person, if they just watch sport, well, our total, if they watch sport but it doesn't say didn't watch anything else, then we have 9, 10, 12 people. So we have the probability that they watched sport to be 12 out of 40. And then we can reduce that down. All right. Part 2, drama and sports. So our probability, let's actually come down here. we go. Probability of watching drama and sport. All right, so here's drama, here's sport. We have 4 people who watch drama and sport. They didn't say and not watch and didn't watch a movie. So we have 4 people, also randomly selected out of our total. So 4 out of 40. We can reduce that down to 1 and 10. And then part 3, a movie but not sport. So they did watch a movie, but they did not watch sport. So we're not going to include these 3 people who watch sport. So then we have 7. Movie intersect with not sport is going to be, what did we just say, 7 out of our 40 total. Then we come down to part 4, drama but not a movie. So they watched drama, but they did not watch a movie. So here we do not include these 4 people. So we have 12 here, 3 here, so we've got 15. So the probability of watching drama, or a movie, oh no, we're still on 4, but not a movie. So drama and not including a movie, so the complement of movie. Drama, not a movie, we have 15 out of 40. And we can reduce that down by 5, so we get 3 out of 8. And then our last section, drama or a movie. So the probability of drama or a movie, which also includes the possibility of both. So drama or a movie includes both of these full circles. So for this one, drama or a movie, if we include all of these, I think it comes out to about 25. Yep, so 25 out of 40. And then we can reduce this down to 5 over 8. All right, there are various different questions that could also be asked with a Venn diagram like this. So one could be probability of a drama or sport and including not a movie. So we'd be looking at drama or sport, so these 2 circles here, but not including a movie. So if we do not want to include a movie, then we need to make sure we are saying just the 6, 9, and the 12, so 21 out of 40. You could also be asked a given scenario. Given the person watched a movie, what's the probability they also watched some sport? So if we have the probability that the person watches a movie, watches sport, given that they've watched a movie, we use that diagonal slash there. That means that the denominator is our subset of people who just watched a movie. So given that the person watched a movie means we're only looking in this circle here. So we're only looking at the 10 people who watched a movie. So our denominator would be 10. And then out of those 10 people, what's the probability that they watched some sport also? So out of those 10 people, we had 3 people who watched some sport. So then 3 out of 10. So as soon as we have a given scenario, we've changed our denominator because we're looking at a subset, okay? So our sample space changes. Last but not least, in H.2, we're asked to verify set identities. So here we're asked to show that A union B complement is the same as not A intersect with not B. So we'll do that by using our Venn diagrams, and sometimes you might need to use multiple colors or different strokes. So you might want to use a sideways this way and maybe a sideways that way to show an overlap. So we'll do that since if you're just using one color on your exam, you might need to find different ways to show what's going on. So A union B we know is the set of the 2 sets and the intersection, but then complement, meaning we're just talking about everything outside. So that means this is where our focus is. So for this one, we're just showing that we can identify what part of the Venn diagram we're talking about. Then when we come over to verify that it's the same as the intersection of not A and not B, I'm going to use 2 colors for this. So not A, meaning everything that's outside of A, but that also means it would include everything that's in B, but not in A. Okay, so here's our green part. That's not A. Then we have the red, or I'll use blue actually, for not B. So anything that's not in B would include everything that's outside, but also it will include what's in A as well. So we're talking about all this space here. And what I'm looking at is the intersection of the 2. So where did the blue and the green overlap? Well, the blue and the green overlapped outside of these 2 circles and the intersection. meaning that we're actually looking at the exact same space that we showed in the left Venn diagram as well. Okay, so we're just verifying by showing that yes, this actually comes out to be the same space that this left one is. So when you're asked to verify, go ahead and set up two Venn diagrams, show what part of the Venn diagram you're discussing, and then show that they are actually going to be equal to each other. All right, have a fantastic night, IB. We'll see you guys tomorrow.